I made a video before talking about the fly in a train theory, but it was not well explained. So here is the fly in a train theory debunked, part 2. So the fly in a train theory is evidently about a fly in a train. This theory states that if a fly is flying backwards at the same speed as the train is moving forwards, does that mean that the fly is not moving at all? Well, the answer to this question is simple. Since they're both equal, they will cancel out, so the fly is technically not moving, while the train is still moving forward. But the fly will eventually hit the back of the train. This theory also states that if the fly is flying forward inside the train, doesn't that mean that the fly is technically flying faster than the train? The last thing that this theory states is that if the fly is not touching the train, then won't the fly start moving backwards because the train is moving forward but the fly is not moving with the train? To solve the first two parts of this theory, we have to learn about something called relativity. Relativity is what one thing is to another thing. One example of relativity is when you're driving in your car and a truck comes by and it's driving at the same speed as you for, say, 30 kilometers an hour. From your perspective, the truck will seem to not be moving at all since it's traveling at the exact same speed as you. In the same scenario, if the truck is moving at 40 kilometers an hour and you are moving at 30 kilometers an hour, then from your perspective, the truck will be slowly moving forward as the truck is moving faster than your car. This is an example of relativity because it just shows what the truck seems like relative to you, but it might seem different relative to someone who isn't in a car and is just standing outside. Now let's add this to our theory. From the perspective of a person standing from the outside, it would seem that the ball is traveling faster than the train. And if you put a speedometer, which is what police use to measure speed, inside of the train and measure the fly's speed, it will register that the fly is traveling at 1 kilometer an hour, since the speedometer is also moving with the train, so the speedometer will not register the train's speed. But if you were to put a speedometer on the outside to measure the fly's speed, it will show you the fly's speed plus the train's speed added up, which is the fly's actual speed. And this is because the fly is already moving with the train, meaning that the fly will travel at the train speed. And the fly itself is also moving. So you gotta add the current movement of the fly on top of the fly moving with the train, which will lead to 21 kilometers an hour. Now to cover the first part. This part of the theory states that the fly is moving backwards at the same speed that the train is moving forwards. And relative to someone on the outside of the train, it would seem that the fly is not moving at all, since the fly's speed cancels out the train's speed, since they're moving at the same speed, and since they're moving in opposite directions, they both cancel out each other, meaning that the fly will not be moving at all. But relative to someone on the inside of the train, it would seem that the fly is moving backwards, since on the inside of the train, you can't really register the train movement, since you're moving with the train. The last part of this theory states that if the fly is not connected to the train in any way physically, then the fly should technically be moving backwards, since the train is moving forwards and the fly is not moving with the train. But this does not happen, since inside of a train, there are a bunch of air molecules that move with the train. And these air molecules push other things inside of the train. So really, the fly will still move with the train, since the air particles will be pushing on the fly. And since the air particles are being pushed by the train, then the fly will also be pushed by the train, since the train pushes the air particles, and then the air particles pushes the fly. And there you go. That's the fly in a train theory debunked.